4 hours ago, something happened above our heads that should not be possible. This is not a simulation. It is not a theory. It is not speculation about some distant future. It is a recorded event that ended just hours ago. At exactly 8 UTC, on the 26th of February 2026, low Earth orbit was operating normally. Satellites were transmitting. Navigation systems were stable. Weather data was flowing. And then, within 6 minutes, 214 active satellites over the northern hemisphere went silent. By 8/6 UTC, ground stations across multiple continents had lost contact. This was not a solar flare. It was not a collision cascade like the feared Kessler syndrome. According to data from NASA's Goddard Space Flight Center, the disruption came from a coherent, directed electromagnetic pulse originating deep in space. The coordinates trace back to an object known as 3I, Atlas. Let that sink in. We are talking about something officially classified as a comet, an icy remnant drifting through space, producing an energy burst powerful enough to disable hardened military-grade electronics from a distance of 180 million kilometers. The level of focus required to do that challenges everything we understand about natural celestial bodies. The telemetry logs reveal something even more unsettling. Solar storms behave like shotguns, spreading charged particles in wide arcs. This event was different. It behaved like a precision strike. The pulse bypassed Earth's magnetosphere. It ignored the Van Allen radiation belts. It struck satellites traveling in a specific orbital inclination of 53 degrees. Nature does not usually operate with that kind of precision. Chaos is normal. Entropy is expected. A 6-minute window of targeted destruction is not. At 7:58 UTC, 2 minutes before the blackout, NASA's Deep Space Network detected a spike in the high-frequency radio spectrum. Ionization levels in the upper atmosphere jumped by 400%, but there was no time to react. No window to rotate satellites into safe mode. The event unfolded faster than any mitigation protocol could handle. The real question is not how much damage was done. Engineers can count debris. The deeper question, the one being discussed quietly in rooms at Jet Propulsion Laboratory and European Space Agency, is far more serious. If 3I, Atlas, is just a comet, where is this energy coming from? And if it is not just a comet, what exactly has entered our solar system? To disable a Starlink V2 satellite from beyond Mars's orbit would require energy comparable to the output of a mid-sized nuclear power plant compressed into a focused beam the width of a city. Seeing that kind of emission from an icy object suggests that our classification may be wrong. More troubling still, the evidence suggests the 6-minute blackout was not random. It may have been a test. To understand how 214 satellites went offline in 6 minutes, we need to rewind to the beginning and examine what 3I, Atlas, was believed to be. The object was first flagged on the 19th of December 2025 by the Atlas survey. The I designation indicates an interstellar origin, similar to the object Oumuamua discovered years earlier. Its trajectory appeared hyperbolic, meaning it would swing around the Sun once and leave the solar system permanently. The scientific community was intrigued but calm. We expected rock, ice, a silent visitor obeying classical orbital mechanics. Within 48 hours, that assumption began to unravel. On the 4th of January 2026, the Hubble Space Telescope attempted to measure its rotation period. For a natural asteroid or comet, this is straightforward. As it tumbles, reflected sunlight creates a smooth light curve that rises and falls predictably. But 3I, Atlas, did not behave that way. Instead of a gradual oscillation, the light curve was flat for 6 hours. Then, without warning, luminosity spiked by 400% for exactly 0.3 seconds. Then it returned to flat. In astrophysics, natural bodies do not behave like digital switches. They do not flick on and off. Yet this object produced a rhythmic stroboscopic flash every 14 hours and 22 minutes. At first, instrument errors seemed likely, a detector glitch, a stray cosmic ray. But confirmation followed. NASA's Deep Space Network recorded the same spike at the same moment. The European Space Agency's Gaia Observatory, positioned at the L2 point, observed the identical flash. Then the Very Large Array in New Mexico detected a synchronized radio burst down to the millisecond. 3 independent systems. Different instruments. One conclusion. The object was not simply reflecting sunlight. It was emitting energy. And that realization changed everything. Because once an object begins emitting structured signals instead of passive reflections, you are no longer observing a comet. You are observing behavior. And behavior demands explanation. When the pulses from 3I, Atlas shifted into the L-band spectrum, the situation moved from unusual to deeply unsettling. The L-band is not just another slice of the electromagnetic spectrum. It is the range used by GPS systems, weather satellites, and critical communication networks. It is the backbone of global positioning, aviation guidance, maritime navigation, and portions of military coordination. Out of billions of possible frequencies, this interstellar object began emitting structured signals directly inside the narrow band that supports modern civilization. By February 10, as 3I, Atlas passed beyond the orbit of Mars, expectations were clear. At that distance, the sun's influence weakens. Solar wind is reduced. Heat levels are minimal. A normal comet should be dormant, frozen, solid, showing little to no activity. Yet, on February 12, spectral analysis revealed a change. The earlier light pulses transitioned into microwave emissions, concentrated precisely within the L-band range. The probability of a natural interstellar body spontaneously broadcasting in a telecommunications band used by Earth is astronomically low. It would be like picking up a stone on a beach and discovering it transmits FM radio, yet data from the Green Bank telescope showed something even more structured. As the object approached the inner solar system, the signals did not remain broad or chaotic. They narrowed. The bandwidth tightened. The frequency stabilized. It was as if the source was tuning itself. Scientists tried to explain it away. Plasma interaction, exotic solar wind effects, instrument artifacts. Every conventional model was applied in an effort to fit the observation into known physics. But 6 hours ago, those assumptions collapsed. The pulses were not random noise, they were building charge. Trajectory updates delivered shortly before the blackout introduced another problem. Comets move according to gravity. Their paths are dictated by mass and velocity, described by Newtonian mechanics for over 3 centuries. But 3I, Atlas, began to deviate from its predicted orbit. In normal circumstances, when a comet approaches the Sun, ice sublimates into gas. Jets form, creating small thrusts that slightly alter trajectory. This is called non-gravitational acceleration. It is chaotic and dependent on heat. But 3I, Atlas, was positioned 2.1 astronomical units from the Sun beyond Mars's orbit. Solar flux, there is less than half of what Earth receives. Water ice remains frozen. Methane ice barely sublimates. Natural thrust at that distance is negligible. Yet over 48 hours, the object accelerated by 0.04 kilometers per second. On paper, that sounds minor. Over millions of kilometers, it is massive. Even more troubling was the direction. Instead of accelerating away from the Sun, as natural outgassing would dictate, 3I Atlas shifted perpendicular to solar gravity. It made what can only be described as a left turn. In the vacuum of space, objects do not bank like aircraft. There is no atmosphere, no friction. To alter velocity at a 90-degree angle requires directed thrust. When modeled assuming a 400-meter body with average comet density, the energy required reaches approximately 150 meganewtons of continuous thrust sustained for 6 hours. If this were natural outgassing, the entire surface would need to erupt simultaneously in a perfectly aligned direction. Infrared observations showed no massive dust cloud, no expanding coma, no tail. The object remained cold and dark. Colleagues specializing in orbital dynamics proposed a collision scenario. Perhaps 3I Atlas struck a smaller asteroid, altering its path. But collisions generate debris and chaotic spin. Radar data from Goldstone Deep Space Communications Complex showed the opposite. Before the acceleration event, the object exhibited mild tumbling. Afterward, rotation stabilized, the axis locked into a fixed orientation, and that axis pointed directly at Earth. Consider the implications carefully. We have an interstellar object emitting structured L-band signals. It demonstrates controlled, non-gravitational acceleration. It stabilizes its spin. It aligns with our planet. This is no longer consistent with cometary physics. Then came the maneuver itself. During the left turn, instruments detected a specific electromagnetic signature. It matched the ionization pattern recorded in Earth's upper atmosphere hours later during the satellite blackout. The maneuver was not simply navigational. It appeared to be alignment before discharge. Everything up to that point was preparation. At 8 UTC, the first interference wave reached low Earth orbit. Engineers at the European Space Agency Control Center monitoring Sentinel-6 observed voltage surges rising rapidly across solar arrays, 400% above baseline, then 800%, then immediate failure. The pattern repeated, satellite by satellite. But this was not a single burst. It was sequential. Satellite A failed at 8 hours 1 minute and 12 seconds. Satellite B, positioned 400 kilometers east along the same orbital plane, failed at 8 hours 1 minute and 15 seconds. Satellite C followed 3 seconds later. The sweep speed calculates to roughly 133,000 kilometers per hour. This was not an explosion, it was scanning. The beam moved mechanically across a precise orbital shell. It struck communication satellites, weather platforms, and at least one classified payload whose mission remains undisclosed. The precision required to intercept specific orbital inclinations implies knowledge of satellite positions, not just in real time, but predictively. At 8:06 UTC, the sweep ended. 214 satellites were silent. Billions of dollars of infrastructure drifted powerless in orbit. Then something even more unsettling occurred. At 8:07 UTC, exactly 1 minute after the final failure, the emissions from 3I Atlas stopped completely. The L-band signals vanished, high-frequency bursts ceased, infrared signatures faded. For nearly 4 hours, the object remained silent, not fading gradually, not decaying naturally. Instant silence. When the signal from 3I Atlas stopped at 8:07 UTC, it did not fade the way natural phenomena do. There was no gradual decline in energy, no weakening oscillation, no trailing interference. It cut to zero instantly. For scientists who study cosmic radiation, that detail is impossible to ignore. Natural bursts follow decay curves. A magnetar flare weakens over time. A solar eruption disperses. Even chaotic plasma storms lose intensity gradually. Physics demands dissipation, but this object did not dissipate. It stopped. For the last several hours following the blackout, observatories across the globe reported silence. No radio emission, no measurable microwave output, no thermal spikes. It was as if the source had completed a task and powered down. That behavior suggests something critical, a cycle. Earlier data from the Green Bank telescope showed that before the satellite sweep, 3I, Atlas emitted rhythmic flashes every 14 hours and 22 minutes. That interval was consistent, predictable. If the 6-minute electromagnetic sweep followed the same timing structure, then the next active window would open 14 hours and 22 minutes after 8/6 UTC. That places the next potential event at 22:28 UTC tonight, less than 10 hours from the moment the blackout ended. Right now, every major radio observatory is monitoring the object's coordinates. The Deep Space Network is listening across multiple bands. Military radar systems are recalculating trajectory models repeatedly because what happens at 22:28 UTC will answer the question no official briefing has addressed directly. Was this a one-time anomaly, or is it the first stage of a pattern? Let's establish what is no longer in dispute. First, 3I, Atlas has emitted structured signals in the L-band frequency range. That is documented by independent observatories. Second, it has demonstrated non-gravitational acceleration perpendicular to the Sun, consistent with directed thrust rather than passive outgassing. Third, it stabilized its rotation axis and aligned itself with Earth. Fourth, at 8 UTC, it executed a 6-minute electromagnetic sweep that disabled 214 satellites with sequential precision. These are observational facts. They come from NASA, from the European Space Agency, and from independent radio arrays. The official narrative continues to reference a solar anomaly. But solar anomalies do not scan orbital shells in 3-second intervals. They do not selectively target satellites in one inclination while leaving others untouched. They do not cease activity at the exact completion of a sweep. Now consider the trajectory. As of 12 UTC today, 3I, Atlas is traveling at 34 kilometers per second relative to Earth. Its vector still points inward. The acceleration event that altered its course remains unexplained by conventional physics. And if the recharge cycle model is correct, the next emission window may coincide with a closer approach, potentially increasing intensity. There are two broad scenarios. In the first scenario, the signal does not return. Silence continues. If that happens, the satellite blackout may be recorded as an extraordinary but isolated cosmic event, a rare plasma phenomenon interacting with orbital infrastructure in a way never previously observed. It would remain unexplained but contained. In the second scenario, the signal resumes at 22:28 UTC. If it does, the target selection becomes crucial. Low Earth orbit has already suffered damage, but Earth's technological backbone extends further. The geostationary belt hosts communication satellites that enable global broadcasting and data relay. The GPS constellation maintains timing synchronization that supports banking systems, power grids, and transportation networks. If the next sweep shifts to one of those orbital shells, the implications escalate dramatically. That would indicate pattern recognition and strategic progression. Another variable must be considered. During the left-turn maneuver earlier, energy readings indicated that while 3I Atlas was adjusting its trajectory, it was also accumulating charge. The ionization pattern observed in Earth's upper atmosphere during the blackout closely matched the electromagnetic signature detected during that maneuver. This suggests the alignment was not incidental, it was preparatory. In orbital mechanics, comets do not pause to orient. They do not conserve energy for timed discharge. They follow gravity. Yet 3I Atlas appears to be conserving energy between events. The silence we are hearing right now may not be inactivity. It may be recharge. Engineers are recalculating shielding tolerances. Satellite operators are discussing emergency orientation protocols in case another pulse is detected. The challenge is that reaction time appears minimal. The precursor spike 2 minutes before the blackout was insufficient to prevent damage. If another pulse begins tonight, mitigation windows will again be measured in seconds. There is also the broader scientific consequence. If an interstellar object can demonstrate controlled thrust and structured electromagnetic emission, then our classification framework for celestial bodies requires immediate revision. The designation comet becomes inadequate. This is no longer simply about lost hardware. It is about understanding whether we are observing a natural anomaly that challenges physics or an engineered system operating beyond our current technological baseline. The clock continues toward 22:28 UTC. As we approach 22:28 UTC, the tension is not coming from speculation, it is coming from pattern recognition. If 3I Atlas follows the same 1, 4 hour and 2-minute interval observed in previous emissions, then tonight is not random. It is scheduled. The most important variable is not whether the signal returns, it is where it points. Low Earth orbit has already taken the hit. 214 satellites are now silent, drifting hardware that once powered communications, navigation, environmental monitoring, and defense systems. But Earth's infrastructure extends beyond that orbital layer. Above it lies the geostationary belt, a ring 35,786 kilometers above the equator, where satellites remain fixed relative to the surface. That orbit carries broadcast television, long-range communications, weather forecasting, and strategic military relays. If the next emission targets that altitude, the consequences multiply instantly. Then there is the GPS constellation, distributed across medium Earth orbit. Those satellites do more than guide maps on phones. They provide timing, synchronization to financial networks, stock exchanges, power grids, and global logistics systems. A disruption there would not just affect navigation, it would ripple through the world economy within minutes. This is why the silence since 8/7 UTC is more unsettling than the initial strike. Silence implies control. If the blackout had been caused by a chaotic solar phenomenon, we would still be seeing residual fluctuations. Space weather monitors would detect lingering instability. Instead, every instrument trained on 3I Atlas reports nothing, no excess radiation, no broad-spectrum leakage, just a cold, dark object continuing its inward trajectory that still defies expectation. Updated orbital models confirm that the object's previous acceleration was not random drift, it was sustained and directional. The energy required to execute that maneuver remains unexplained by cometary physics. No visible outgassing plume, no expanding debris field, no thermal bloom that would indicate surface sublimation. The mass appears stable. The rotation axis remains locked toward Earth. Orientation is not passive. There is another factor that demands attention. The electromagnetic signature captured during the 6-minute sweep matched the ionization spike recorded in Earth's upper atmosphere. That means the beam was not diffused by distance, it was coherent, focused, directed. Coherent emissions at that scale require structural stability at the source. Natural bodies fragment under uneven stress. They tumble, they shed material. Yet 3I Atlas appears structurally intact after delivering energy comparable to the output of a power plant compressed into a beam. If the signal returns tonight with increased intensity, proximity becomes critical. The closer the object moves, the less energy required to achieve the same destructive effect. In other words, even if the output remains constant, impact efficiency rises as distance shrinks. There are only a few logical possibilities. 1. This is an unknown natural mechanism that mimics intentional behavior with astonishing precision. If so, it represents a breakthrough in astrophysics that will rewrite textbooks. 2. It is an artificial structure of interstellar origin operating autonomously. The second possibility is extraordinary, but so are the observations. Governments are currently maintaining controlled messaging. The term solar anomaly continues to appear in briefings. Yet internal recalculations within NASA and the European Space Agency are focused not on solar modeling, but on emission prediction windows. That shift in analytical focus speaks volumes. If 22:28 UTC arrives and passes without event, the tension will ease temporarily. Investigations will continue, but urgency will drop. If 22:28 UTC arrives and another structured pulse begins, especially if it sweeps a different orbital shell, then the conclusion changes fundamentally. That would confirm sequence. Sequence implies intent. Intent implies design. And if design is confirmed, humanity will face a question we have never had to answer in practical terms. How do you respond to a technological system that originates beyond your solar system and demonstrates capabilities beyond your own? Interception is not feasible at current distances. Even our fastest probes would take months to adjust trajectory. Directed energy countermeasures at that scale are theoretical at best. Shielding satellites against a coherent beam of that magnitude would require redesigning entire constellations. In short, reaction time is minimal. Right now, observatories remain locked on target coordinates. Data streams are being recorded continuously. Analysts are watching for the faintest shift in frequency or heat signature. The next few hours will determine whether the 26th of February, 2026 is remembered as a rare cosmic anomaly or the first documented encounter with something engineered beyond Earth. The clock is moving toward 22:28 UTC. If the signal returns, we move from confusion to confirmation. If it remains silent, we move from crisis to mystery. Either way, this moment marks a turning point in how we understand objects entering our solar system. Stay informed, stay critical, and if you want real-time updates as this situation develops, make sure you subscribe, turn on notifications, and follow the channel so you do not miss what happens next.